Hello, guys. Welcome back to Math Zone African Motives. We are still on our mathematics N5, and in this case, we are going to consider the revision, which is from our November 2025 exams. So we are going to work out the questions. So make sure that you do watch from the playlist, all right, so that you can watch all the videos. I'm going to break them into pieces so that you can have a clear understanding of the topic also, for those who want to specifically work with a certain topic. So the first part that you're going to have is on our limits and continuity. That was our question number one. And you were given 1.1 to determine the following limit. Determine. All right. This question paper, if we are to consider, most of the questions, they were having errors in terms of the answering the memo, and also some of the questions being displayed. Like this one, it was actually supposed to be the infinite used here, but according to what we are given, this is what we are going to have when x is approaching to 0. All right, because under exam, this is what you'll be having. No one is going to tell you there was supposed to be a limit, which is infinite there. No. If you had to work with this, you're going to substitute in place of x, you put a 0. So that was going to be a 0 here plus e to the exponent of 0 is 1. Any number to the power of 0 is 1. Everything over what? That's a 0 here plus that's a 0 again. 5 times 0, that's a 0. So meaning to say y is going to give us this 0 plus 1, which is 1 over what? 1 over 0. Remember that a constant over 0 gives us what? Infinite. So y was going to give us infinite. This is what we were going to have, all right? This is what you're going to have. But in a basic consideration of our N5, they are not going to give us a basic question like that where we are not going to apply our derivatives, the L'Hospital's rule. So in that case, it was supposed to be actually n infinite. So let us just work with n infinite and see how it was going to be like x approaching to infinity like this. And that's 3x squared plus e to the exponent of x over 2x cubed plus what? 5x. This is what you were going to do in a case like this. You were going to put the infinity, all right? That's substituting. Remember, if you take an infinite raised to a certain exponent, guys, if it is positive, it's just going to be infinite. And also, a number, if you take a certain number, all right, let's just k to the exponent of infinite, that will be infinite again. So meaning to say, here it was just going to give us infinity over infinite because it was just going to be, you're adding infinity to infinite, which is just infinite. So this is what you're going to have, meaning to say we have the indeterminate form, all right? A mathematical expression whose limit we cannot determine even after substitution of what the limit infinite over infinite is, indeterminate form. So meaning to say we must apply our L'Hospital's rule where we must find the derivative of the numerator and the denominator. So we must find what? The derivative of both. So this is what you're going to have as x approaches to infinite. You're going to differentiate 3x squared, simply drop the power and subtract 1. So here you're going to drop the power. Then we subtract a 1. That's 6x. So it's going to be 6x. E to the exponent of x is going to remain like that. All right. Remember the derivative of e to the exponent of x. All right, let us just also consider our formula sheet for the sake of understanding for this part. E to the exponent of x on its derivative is gonna remain like that if it is e to the exponent of what? Of x. So this is what you're going to have. Then the denominator, drop the exponent, multiply the 6 and subtract 1. So it's going to be 6x squared plus what? Plus 5. So this is it. We substitute the limit again. You can see it's going to be infinity, infinity there. And this is going to be infinity plus 5, which is what? Infinity. So we still have the indeterminate form where we must differentiate again the numerator to the denominator. All right, so this is what you're going to have. The derivative of 6x, the 6e, remember, it remains like that, e to the exponent of x. This, you drop the exponent here, multiply this 12 times 2, which is, 6 times 2, which is 12. So it's going to be 12x plus what is 0. So that's simply 12x. So this is what we have, substituting our infinite. That is going to be infinity over infinity. All right. 6 plus infinity, guys, is still going to give us infinity. All right. So that's, we have to differentiate again. Differentiate again until we have what? A format which can be simplified. This cannot be simplified. So this was going to be limit as x approaches to infinity of what? The derivative of 6, that's a 0. E to the exponent of x remains as it is. All right, then 12x is going to give us what? 12. So this is what we have. And this e to the exponent of infinity is going to give us what? Infinity over 12. All right, this can be simplified. So if we've got infinity over 12, that's infinity over a constant, still that is going to give us what? Infinity, if you are to simplify this. So this is what you're going to have at the end. So I'm just taking to say, if we had that condition, where our limit is what? Is an infinite, this is what you're going to have. So do more revisions, and also join the membership, all right, so that you can have more access to the other classes, revisions, and so on. All right, so that is it for all your N5. You just join once and get access to all subjects under N5. It is not only for a single subject, all right? That is for all subjects that are under N5 and N6. All right, so that is what you had. Just saying here, it was a mistake. It was supposed to be infinity, but under exam, you were supposed to use the way that I answered when x approaches to 0, because this is what you have. You answer what you are given as it is. All right, let us continue to question 1.2, which is given to determine the value or values of x in the domain 0 to 360. Our angle or our answer must be taken in within the given domain, for which f of x is discontinuous. Is what? Discontinuous. A state that we do understand if a over b to be discontinuous, b is supposed to be equal to 0. B must be equal to 0, the denominator. So given f of x, which is equivalent to the sec of what? Of x. We do not have a fraction that we can say the denominator is. We do not have that. So what are you going to do? Remember, the sec of x is equivalent to what? 1 over cos. So we can use that, right? If you understand that cos, it's 1 over sec. 1 over sec, it's a cos. So the opposite, if we say 1 over sec of x is going to give us what? Sorry, the opposite. I mean, this is, let me put it this way. All right, the opposite, if we take this sec, the sec of x, it means it's going to be 1 over cos of x. Simply 1 over this gives us a sec, and this will be 1 over cos. So that is the reciprocal of what you're given. But if this one you're supposed to understand and know it, so meaning to say it is the same as 1 over the cos of x, where we have a fraction. The denominator must be equal to 0 for this f of x to be discontinuous. So you work with the denominator. The cos of x must be equal to 0. So solve for x within the given domain. We are back to our trigonometry and for mathematics. All right? So where is the cos of x? All right, remember, cos and sine, these two, you must know them, guys. The sine of x to be 0, I explained this in N4 from our graph of sine. It is 0 at what? 0. And at this point, 180 and what? 360. Within from 0 to 360. You know that your x must be equal to 0, must be equal to 180, must be equal to 360 degrees. If it is for the cos of x, you take it from the graph of what? The cos of x. Where it is equal to 0 at this point and at this point, which is what? 90 degrees and 270 degrees. This is 180 in between. So 90 and 270, there the graph will be at what? At 0. So that is the condition. Even if you had to use your calculator, arc cos of what? Arc cos of 0, this is going to give you what? This is going to give you 90 degrees. But you need another solution. You need another solution. So the other solution will be at 270 degrees. Within 0 to what? To 360 degrees. So x can be equal to 90 degrees, or it can be equal to 270 degrees. The cos of 270 degrees must give us what? A 0. This is what it means. The cos of 90 degrees must give us a 0, because we are saying the cos of x, where x is the angle, gives us 90 degrees. So for 0 and 1, 0 and 1, those are special values that you must know them by what? By head. When it is 1, you know that if it is for the graph of sine, positive 1 is happening at what? At 90 degrees. Negative 1 is now happening at what? 270. If it is the graph of cos, 1 is happening at what? At 0 degrees, you'll be having 1. At 360 degrees, you'll be having 1. So meaning, say the values of x will be 0 and what? 360. If the cos of x is equal to what? If the cos of x is equal to 1. Meaning to say your x is what? Your x will be equal to 0 degrees, or your x will be equal to 360 degrees. Those are critical values and special angles that you must know under your trigonometry, because it is also can be taken from the graph. Or if you do not understand this one, guys, the advantage is that, let's say you have a confusion. All right, the advantage is that these angles that we are referring to as our solutions for when you are considering the cos of x is equal to 0, the sine of x is equal to 0 or 1, or it can be negative 1. These are being taken from special angles. So what you just do is that you work with those angles, which is 0, 90, 180, 270, and what? 360 degrees, from 0 to 360. So these are angles that you can even try and substitute on your calculator to say the sine of 0. What is the answer? It's 0. The sine of 90 degrees, what is the answer? So if you are given that the sine of x must be equal to 0, you just try up to what? Up to 360. Which ones are giving, which of the values will give you exactly 0. You move on, sine of what? 180 degrees. You know that x must be what? 180. You move on 270 up to what? 360 degrees. The sine of 360 degrees, it gives you a 0. So you know that those are the values of x, the angles that you're substituting. 0, 180, 360. Those will be your solutions. It is something that you can even use your calculator. Even when it is 1 or minus 1, use your calculator. Where you are obtaining 1, that's the angle that is representing x. You are done. You're done. So this is about revision now. So we are going to move on to the second question and so on and so on. So like I said, make sure that you do follow up the playlist, all right? Up to the end, I'm going to put a playlist where you can access all the videos up to the end. So this is it, guys, till we meet again.